Hello dear students, hope all doing well. You know me already, right? I am Vinith, I am your senior chemistry faculty. So today in this session we are going to learn metals and non-metals, okay? So hope everybody join the live session. Hello sir, hi. Yes, previous session was good sir, thank you so much. So we'll wait for 2 minutes so that everybody can join the session. So what metals and non-metals are? Okay. So in day-to-day life we can find metals and non-metals in everywhere. Without metals we cannot live. Like metals are everything. So like in the minerals also, like iron, magnesium, calcium, which are very essential macronutrients for our body, and also macro minerals. So these are very important for our body, not only biological activities but also the physical activities day-to-day life. So we need different types of metals for the daily purpose, and also non-metals. So non-metals are nothing but plastics, carbon compounds, like there are many non-metals we are using daily, okay? So in this units we will learn the chemical properties of the metals and chemical properties of the non-metals, and how can we prevent the corrosion and the types of chemical reactions with the examples, okay? So let me start the session. Hope everybody join the session. Yes, hello sir, hello. Yes, let's start, okay? So metals and non-metals. So what are metals and what are non-metal according to the chemistry? We know that metals are having some properties, physical properties and the chemical properties, and non-metals also having the some physical properties and chemical properties that differentiates the metals and non-metals. So according to the chemistry, what are metals and what are non-metals? So today in this session, what are we going to study? Okay, first is physical properties of the metals and non-metals, chemical properties of the metals and non-metals. Under this, we are going to study the reaction with air, water, acid, metal salts, and metals and non-metals. Next, properties of the ionic compounds. So ionic compounds will be the new word in this complete 10th grade. So ionic compounds. So there are different type of compounds like covalent compounds, ionic compounds. So this will be the new word. And activity based explanation, like chemical properties can be explained with the help of activities. And last is NCERT questions. NCERT questions, the questions which are at the end of the unit will be discussed in this session. So these are the topics we are going to cover in this session. So introduction. What is introduction about the metals and non-metals? So first let me tell you that metals are nothing but, according to the chemistry, what are metals? So let me take one example, sodium. Okay, sodium is the metal which belongs to the S block of elements. That is nothing but the alkali earth metal. Okay, sodium atomic number, what is the atomic number of sodium? 11. Yes, sodium atomic number is 11. So electronic configuration, K, L, M, and electronic configuration. So here we have 11 electrons, 2, 8, 1. 2, 8, 1. The outermost electron is 1. So as we already discussed that whenever there is a less than 4 electrons in the outermost shell of an atom, the atom will try to donate the electrons. Whenever it is more than the 4 electron, it is try to gain electrons. So here we have less than 4 electrons. That means this sodium element will try to donate the electrons. So sodium will give 1 electron, becoming Na plus and 1 electron. So why it is Na plus? We already discussed in the previous chapters, that is acids and bases, and also in the chemical equations and reactions. Okay. So in this Na plus, because the electrons number is decreasing and protons number is increasing. So here Na plus, and let me take another example, which is chlorine. Chlorine atomic number is 17 and the KLMN electronic configuration. KLMN electronic configuration 2, 8, 7. Here if you observe 7 electrons in the outermost shell. So that means this chlorine will try to accept electrons to become stable. So atom will tries to be in stable state by following the rule called octet rule. So here there are 1 electrons, it is difficult to gain 7 electrons. Rather than taking 7 electrons, it will donate 1 electron. Whereas here so it is easy to take 1 electron rather than giving 7 electrons. So here chlorine will take 1 electron becoming Cl minus. Cl minus. So remember, according to the chemistry, the one which donates the electron is called metal. So sodium will be metal and the one which gains the electron is called non-metal. So chlorine will be non-metal. Okay, chlorine will be non-metal, whereas sodium will be metal. So let me repeat once again, the one which donates the electron is called metal, the one which accepts the electron is called non-metal. So here is what the introduction of the metals and non-metals. We got to know that cations are metals. This is cation, cations are metals, whereas anions are non-metals. Okay, anions are non-metals. Hope you understand about the cations and anions, metals and non-metals. So metal is nothing but cation, non-metal is nothing but the anion. So next, physical properties of the metals and non-metals. So physical properties can be identified with the help of with our naked eye. That means this physical properties, under this physical properties there are some categories, like first is luster. So what is luster? So luster is the property of shiny nature. So the substance which shows the shiny nature is nothing but lustrous property. So the property by which the metals or non-metal shows the shiny appearance, that is nothing but the luster property. So here metals with shiny nature is nothing but the luster property. So metals will obey the luster property. Next is hardness of the metals. So when you compare with the non-metals, metals are having more hardness. So metals will have the hardness, and second one is luster. First property is luster property and second one is the hardness property, and third is nothing but malleability property. So what is malleability? So when you take the metal and continuously beating on the metal or continuously hammering on the metal, that metal will become into a fine sheet. That property is nothing but malleability property. So metal will have the first property is luster property, second is hardness, and third is malleable. And next, fourth one will be the ductility. Okay, ductile. So the ductility property is nothing but, so the metal can be made into a fine wires. So this is nothing but the ductile nature. So metals will obey the ductility. And next is thermal conductivity and electrical conductivity. Thermal conductivity and electrical conductivity is nothing but, so when you heat the rod, the one end of the rod can transfer the heat from one end to another end. So when you heat the one end of the rod, the heat is being transferred from one point to other point. And also electricity, metals can conduct the electricity. So these properties are nothing but thermal and electrical conductivity that can be obeyed by the metals. So metals can conduct heat and electricity. So next property is sonority. So what is sonority? Sonority is nothing but the property of producing a sound. So when you drop metal and non-metal at a time, metal will make more sound whereas non-metal less, because in the metal the rigidity of the metal and the metal can vibrate more. So that is why the production of sound from the metal is more whereas non-metal is less. Next, so here are some properties. Okay, so here are appearance. So properties with exceptional cases. So metals can obey all the properties given for the metals, but there are some exceptional cases. Like here, appearance is shiny nature, where metals will show the shiny nature, whereas non-metals shows the dull nature, which is non-shiny. But there is some exceptional cases for this non-metal, which is iodine. So iodine is a non-metal, but it shows the shiny property. So this is one of the exceptional cases. Next, hardness. So hardness, so when you compare with the metals and non-metals, metals are having more hardness, whereas there is a non-metal which having the more hardness compared to the metals also, that is nothing but the diamond. So diamond will be the exceptional cases for the non-metals which shows the hardness. Next is malleable and ductile. So in the malleable and ductile, all metals will show the malleability and ductile nature, whereas some metals like sodium, potassium are soft metals. Sodium and potassium are soft metals, they cannot show the malleable and ductile nature. So, and there are some non-metal, sulfur and phosphorus and carbon, which shows the ductile and malleable nature, sometimes they can show. So these are the metals which does not show the malleable and ductile nature. Okay, hope you understand about the appearance and hardness, ductile and malleable for the exceptional cases. Next is thermal conductivity and electrical conductivity. So heat conductivity and electrical conductivity, metals are good conductors whereas non-metals are poor conductors. But in the metals there are some exceptional cases, that is graphite, which is a non-metal which conducts the electricity, and also there is a lead which is lead and mercury, which are also metals, but they does not show the electrical or thermal conductivity. They can show the thermal conductivity. Mercury can show the thermal conductivity, but it cannot show the electrical conductivity. Okay, sonority. Okay, so all metals will produce more sound compared to the non-metals, but in the case of mercury does not show the sonorous property, because mercury is liquid at room temperature. So that is why it cannot show the sound property, sonorous property. The last part is physical property. So the physical properties of metals will be solid, and whereas non-metals also will be in the solid state. But when you compare with the mercury, so mercury is liquid at room temperature, that is why, so mercury does not follow some of the properties of metals, but it is considered as metal because of the chemical nature. So what are that chemical natures? Chemical properties of metals and non-metals, in that first will be metal and non-metal versus oxygen. So metal and non-metal versus oxygen. So when metal or non-metal exposed to the air, what happens? Exposed to the air, see, remember when metal want to react with the oxygen, it takes more time to get oxidized. But here what happens, when you heat the metal, when you burn the metal, it will directly take the oxygen from the environment. So here, let me give one example with the, so here take example magnesium. So magnesium, take magnesium ribbon, and remember there is a precautionary thing is, before doing experiment with the magnesium, take a sandpaper and rub on it unless and until you find a shiny layer, because magnesium ribbon, when it is getting exposed to the air, it gets corroded, it becomes black. So if you are doing experiment with the black color magnesium, so you cannot find the results. So please rub the magnesium ribbon before doing the experiment. Okay. So first, magnesium ribbon, if it is burnt, heated in the presence of oxygen, it gives MgO, magnesium oxide ash. So MgO, which is a magnesium oxide ash, that is here it is not balanced. I think my oxygens are 2, here 1. So keep 2 here, 2 here. So magnesium in the presence of oxygen, when it is burnt in the presence of oxygen, it gives metal oxide. Not only this, any other like calcium, not only calcium in the presence of heat gives CaO. So metal, when it reacts with the oxygen, when it is burnt, when it is combusted, it becomes oxide. So metal on reacting with the oxygen, it gives metal oxide. Okay. What about non-metal then? Non-metal is nothing but, we can take one example, which is carbon. When it is reacting with the oxygen, it gives carbon dioxide. Carbon dioxide or carbon monoxide. So carbon is a non-metal. Non-metal on oxidation, it gives carbon dioxide, which is a non-metal oxide. So this is one of the example for the metal reacting with oxygen. So how to remember these formulas? How to write these formulas? We already discussed in the chemical reactions and equation, which is the first unit of our NCERT textbook. So here, with the help of that, we can able to write the equations. So metal, when it reacts with the oxygen, it gives metal oxide. Remember, general form of the metal reacting with the oxygen is metal. When it reacts with the oxygen, it gives metal oxide. Non-metal also will be the same. Okay. So this is the first chemical property of the metals and non-metals. Second, so after that, there is a question asked in the NCERT textbook, that is, give an example of the metal which is liquid at room temperature. We already know that liquid at room temperature is mercury, which is denoted by Hg. Okay. Can be easily cut with the knife. Sodium or potassium. Sodium or potassium are the soft metals which can be cut with the knife easily, and is the best conductor of heat. So what is the best conductor of heat? See, best conductor of heat will be copper. Okay, we can take copper also, we can take iron also. So let me take iron or copper. You can write anything. Okay, and give an example of a metal which is liquid at room temperature, easily cut with the knife. Sodium and potassium. Is a best conductor of heat. Iron or copper. Is a poor conductor of heat. Is lead. PB, lead or mercury you can take. So only we can take lead. Lead cannot conduct the heat. Explain the meaning of the malleable and ductile. So we already discussed in the table and the previous slide, that is, malleable is the property of a metals. That means, so when the metal is hammered continuously, it becomes a fine sheet. That is nothing but the malleable nature. And the ductile is, so when you make the metal into a fine wires, that property is nothing but the ductile nature. So malleability meaning making a metal into fine sheets, and ductile meaning making a metal into fine wires. Okay, hope you understand these questions. Next, metal and metal oxide versus water. So in the previous slide we already discussed any metal on reacting with oxygen O2, it gives metal oxide. Non-metal also same. So one of the example is nothing but magnesium plus oxygen gives magnesium oxide. Okay, so this is what happens. So when magnesium is combusted in the presence of oxygen, it gives magnesium oxide. But here what happens? Metal or metal oxide in the presence of water. So here this is the series of the metals. So from higher reactive to low reactive. So this potassium, sodium, calcium, magnesium, aluminum comes under the high reactive. Zinc, iron, lead, which comes under the middle reactive metals. So these are low reactive metals. So based upon the reactivity of metals, we will consider the reactions. Like if the metals are high reactive, that means they can react vigorously with the atmospheric oxygen, water, acids, metal oxides and non-metal. So the one with the high reactivity so can react easily with anything, but whereas the low reactive metals is very hard to react with the atmospheric oxygens, water or anything. Okay, so based upon the reactivity series we will differentiate the different types of reaction. So let us assume aluminum, when it reacted with the oxygen O2, it gives aluminum oxide Al2O3. Aluminum, when it reacts with the oxygen, it gives Al2O3 aluminum oxide. So this is a metal oxide. This is a metal oxide. But here what happens? When metal reacts with the oxygen, it gives what? Metal oxide, right? So metal oxide, Mg, when it reacts with oxygen, it gives MgO. This is a metal oxide. This is not balanced. Now it is balanced. Okay. So metal oxide, when again it reacts with the H2O, and again reacts with the H2O, it gives metal MgOH taken twice. This is magnesium hydroxide. Metal oxide, when it reacts with the water, it gives magnesium hydroxide. Okay, so even metal also, when it reacts with the water, it gives magnesium hydroxide. This is the reactivity of metals or metal oxides with the water. So when metal reacts with the water, it gives metal oxide. Metal oxide on reacting with the water, it gives magnesium hydroxide, which is a metal hydroxide. Okay, but what happens in the case of aluminum oxide, Al2O3, on reacting with the H2O, it gives same Al2O3 only. So it does not react with the water very easily. So it will take the oxygen, Al2O3, it will take the oxygen from the water molecule, whereas it doesn't take the hydrogen. So that means based upon the reactivity, they won't react with the completely. They won't react anything with the completely. So let me give one more example. In next slides, we can understand how the metals are reacting with the water. Okay. Type of metal: high reactive, moderately reactive, less reactive and unreactive. Copper, silver and aurum, which are low reactive or unreactive. Okay. So here in the high reactive metals, there are two metals. They are nothing but sodium and potassium. Sodium and potassium react vigorously with the water. That is why, remember, that is why sodium or potassium are stored in the oils or kerosene in the lab. You can find sodium or potassium stored in the oils but not in the exposure of water, because when sodium or potassium exposed to the air, they will react with the water molecule, which leads to the blast. So here vigorous reaction with cold water, not only cold water, hot water also. So any type of water is high reactive towards the sodium and potassium. That gives metal hydroxide plus hydrogen gas. Metal hydroxide plus hydrogen gas. So here metals like magnesium, when it reacts with the water, it gives same magnesium hydroxide, MgOH taken twice with hydrogen gas. And also like sodium or potassium, when it reacts with the water, it gives NaOH plus H2, hydrogen gas. So remember, when metals react with the water, it gives a high reactive metals. Only in the case of high reactive metals gives bases. Okay, magnesium hydroxide, which is called as milk of magnesia. Sodium hydroxide, which is a caustic soda. So metals, high reactive metals. So magnesium and sodium both comes under the high reactive metals. So magnesium and sodium are the high reactive metals. When they react with the water molecule, it gives metal hydroxide with hydrogen gas. But in the case of low reactive metals like calcium, not in the calcium, iron, zinc, aluminum. Iron, zinc, aluminum, they are not giving the metal hydroxide. They will give metal oxide. Because of the less reactive nature. So the metals which are less reactive, when they react with the water molecule, they won't completely react with them. So rather than giving the metal hydroxide, they will give metal oxide. Okay. So here, when iron reacts with the water, it gives iron oxide. Rather than giving iron hydroxide, it gives iron oxide. Okay. So, but in the case of high reactive and moderate reactive, sodium, potassium, calcium and magnesium will give you the metal hydroxide plus hydrogen gas. Whereas iron, zinc, aluminum does not react with they will react with the water, but only they will react with the steam. Only they will react with the steam. So many times they are asking that which type of metals are reacting with the steam and which type of metals are reacting with cold water and hot water. So here are the metals. Sodium or potassium reacts with the cold water and the hot water mostly, and also steam. They will give metal hydroxide plus hydrogen gas. Calcium and magnesium both are light metals, very lightweight metals. So they will float on the water. Remember, they will float on the water. They will react with the only steam, only hot water or steam, but not with the cool water. They will give metal hydroxide with hydrogen gas. Iron, when it comes to the iron, zinc, aluminum, they will react with the only steam, which gives metal oxide with hydrogen gas. Metal oxide plus hydrogen gas. Unreactive metals are copper, silver and gold. Copper, silver and gold, which does not react with the water. Okay, which does not react with the water. So this is what the reactivity of metals towards the water. Okay. Next is metal and metal oxides versus water. So I've already told you this will be the sodium and potassium, which is high reactive towards the water, and hydrogen, which gives metal hydroxide plus. So same table word repeated. So don't worry. Reacts with the steam and hot water, no reaction. Okay. See. So next, metal and metal oxide versus water, there is an activity 3.10. So what is that activity 3.10? Under that activity, we have magnesium. This is the magnesium metal. Okay, magnesium metal which is reacting with the water. So here is the woolen, or you can take any fabric which is dipped in the water, because we don't need direct water. So when cloth is dipped in the water and it is kept in the test tube and magnesium ribbon completely sealed, only we are letting the outlet which is transferred into the delivery tube. Okay. So here what happens, when you give heat to the woolen, it releases the vapor. So hot vapor will travel towards the magnesium ribbon. So magnesium ribbon will react with that hot steam, and it will give what type of reaction it will be? So magnesium, when it reacts with the H2O, it gives magnesium hydroxide plus hydrogen gas. So this hydrogen gas can be identified with the help of ignition test. So this hydrogen gas is transferred to here and it gives hydrogen gas that you can test with the ignition test. And here what happens, magnesium plus oxide gives magnesium plus water gives magnesium hydroxide. Okay. So this is the experiment or activity for the metal and water reaction. Okay. So next, metal reactivity with acids. Okay. Metal reactivity with acids. So in this metal we already discussed in the acids and bases. If you remember, when metals react with the acids, what are the components? So when metals reacts with the acids, it gives salt plus hydrogen gas. So here, so magnesium, when it not magnesium, which is a high reactive, we have other high reactive metals like sodium and potassium also, but sodium and potassium are high reactive. So that is why we are not supposed to do experiments on the sodium and potassium in the lab. So we can do the experiment, but it is very dangerous to deal with the potassium and sodium. So that is why we are doing activity with the magnesium. when it reacts with the dilute hydrochloric acid. Magnesium plus HCl gives MgCl2 plus hydrogen gas. Why only it is giving magnesium chloride? Why not anything else? So here is the reason. Magnesium is a metal. Metal is nothing but cation. Metal is nothing but cation. So when this metal reacts with the acid, it displaces only cation. So cation displaces cation. Mg will displaces hydrogen. It gives MgCl2. MgCl2 is salt. Salt plus hydrogen gas. Salt plus hydrogen. So in the case of zinc also, when zinc reacts with the H2SO4, it displaces the hydrogen. It gives zinc sulfate, salt plus hydrogen gas. So the general form of the metal versus acid is nothing but metal on reacting with the acid gives metal salt. Metal salt means salt plus hydrogen gas. So here magnesium plus HCl gives MgCl2 plus H2. Zinc plus H2SO4, which is a sulfuric acid, gives zinc sulfate, salt plus hydrogen gas. Iron on reacting with HCl gives iron chloride plus hydrogen gas. This is hydrogen gas. Okay. So fast reacting, fast bubbles, heat produce vigorous reaction. So this is high reactive metal. Magnesium comes under the high reactive. That is why the reaction is very vigorous. Whereas zinc is low reactive, steady bubbling, moderate reaction. And iron, slow bubbling, greenish solution. Why it is greenish solution? In acids and bases, and not only in the acids and bases, in unit 1 also we have observed the chemical reaction of the FeSO4, iron sulfate. Iron sulfate exists in the form of green. Okay, iron exists in the form of green color and it is a salt. Okay, so FeSO4 or FeCl2. Okay, it will be in green color. Okay, so this is what happens when metal react with the acid. So metals will react with the hydrochloric acid and H2SO4, but there are some metals does not react with the HCl and H2SO4, but they can react with the HNO3 like copper. Okay, metals below the hydrogen is in the reactivity series such as copper, silver, gold does not react with the acid. Does not react with the acids like HCl and H2SO4. Like copper reacts with the HNO3. HNO3 is nitric acid to form copper nitrate and nitrogen gas instead of hydrogen gas. Why it is giving nitrogen gas? Because it contains excess of nitrogen, oxygen, and hydrogen. So it gives copper when it reacts with the HNO3. It gives copper nitrate plus nitrogen gas H2O. Why it is giving H2O rather than giving hydrogen? Because there are lot of oxygens in the nitrate. So when oxygens are available, hydrogen always tends to make with the bond oxygen. So it gives water rather than giving hydrogen. So here is the reactivity series of the metals with the acids. So high reactive is magnesium. After magnesium, aluminum, zinc, iron, copper. So before this we have sodium and potassium also, but we don't use this. Okay, we don't use this because they are very high reactive towards the, not only towards the acid, water and oxygen. Okay, it is very difficult to deal with them. Next is aqua regia. So gold and platinum are the unreactive metals. They won't react with the water, oxygen and acids like dilute sulfuric acid or HCl. But these can be dissolved with the help of aqua regia. What is it, aqua regia? This is also called as royal water in the Latin. So freshly prepared aqua regia, which contains hydrochloric acid and concentrated nitric acid. Hydrochloric acid HCl plus concentrated nitric acid HNO3. So this is nothing. This is also called as nitrating mixture. It is called nitrating mixture. This is aqua regia. This is the solution which can dissolve the gold and platinum which are unreactive. So remember, always they are asking about the aqua regia. Aqua regia will be in this aqua regia. There will be a 3:1 concentration of the hydrochloric acid and the nitric acid, which can dissolve the unreactive metals like silver and gold and platinum. Okay, this is called aqua regia. Okay, to melt the gold. Next, metal versus the metal salts. So metal versus metal salts, when metal reacts with the metal salts. So we just now discussed what are metal salts. There are many metal salts like MgCl2, magnesium chloride, when magnesium reacts with the hydrochloric acid, zinc sulfate, iron chloride, FeCl2, okay, and there are many like copper sulfate, iron sulfate. These all are metal salts, okay. So how the reactivity of metal and metal salts will be? So metal on reacting with the metal salts, it can displace the low reactive metal. So when the high reactive metal is reacting with the low reactive metal salt, so high reactive metal can displace the low reactive from the salt. So this is nothing but the metal and versus metal salt reaction. So this is the example for single displacement reaction. So I will give you one example. Let me give you one example. This will be the activity 3.12. So under this we have metal reacting with the metal salt. So when iron, see here there is a iron, this is a iron nail, this is a copper wire. It is dipped in. So iron is dipped in the copper sulfate solution and copper is dipped in the iron sulfate solution. So what happens when the iron nail is dipped in the copper sulfate solution? So in previous slide, if you observe, iron is here, which is high reactive than the copper. High reactive than the copper. So let me know, children. So when iron reacts with the copper, so which is the high reactive? According to the reactivity series, iron is high reactive than the copper. So can iron displaces copper? Let me know in the comment section. Yes, yes. So iron can displace the copper because iron is high reactive than the copper. Iron displaces the copper. It gives iron sulfate plus copper. Initially it was blue in color, which converts into green color. So this solution gives green color just because the iron is high reactive than the copper. Iron displaces copper. The blue color solution turns into green. So this test tube A shows the reactivity which turns the blue color solution into green. So next reaction, copper reacting with the iron sulfate. Copper is less reactive than the iron sulfate, so it cannot displace the iron sulfate. So no reaction in the test tube B. Okay. So remember, metal when it reacts with the metal salts, the metal can displace the metal salt from the metal salt only when the alone metal should be high reactive than the metal in the metal salt. Let me repeat once again. So when metal reacting with the metal salt, this metal should be more reactive than the metal in the metal salt. It can displace the metal from the metal salt. Whereas the metal which is low reactive than the metal salt, it cannot displace the metal from the metal salt. So this is nothing but the single displacement reaction. Okay. Hope you understand the metal versus metal salt. So let me repeat once again. Metal when it reacts with the low reactive metal salt, it can displace. So when it reacts with the high reactive, it cannot displace. So reaction proceeds or reaction does not proceed. This depends on the reactivity series in this reaction. Okay. This is what the metal versus metal salt. Next, same reaction. Okay. This is also same reaction, metal versus metal salt. So there are some questions. Why sodium is kept immersed in the kerosene oil? As we already discussed that metal like sodium and potassium are high reactive towards the water. So when metals, sodium and potassium, when it is kept exposed to the air, it will start reacting with the air which is vigorously. So they can give the flame also, which leads to the blast. So that is why the metals like sodium and potassium are kept immersed in the oils like kerosene oil and any type of liquids. Okay, but they should not kept immersed in the water, or it should not exposed in the air. Next, write equation for the reactions of iron with the steam and calcium and potassium with water. So iron with the steam. So when iron reacts with the steam, H2O, it gives, already I told you, when iron reacts with the H2O, iron is less reactive toward the cold water. It can react with the, in the previous slide, if you see here, in the reactivity, iron when it reacts, only it reacts with the steam. So iron when it reacts with the steam, it gives metal oxide. So metal oxide means metal oxide Fe2O3, Fe2O3 plus H2 hydrogen gas, H2 hydrogen gas. This is what happens when the metal reacts with the water. Next is calcium reacting with the water. So calcium is high reactive. When it reacts with the water, it gives H2 calcium hydroxide plus hydrogen gas, okay, calcium hydroxide. High reactive metals give the hydroxide, low reactive metals give oxides. Next, potassium is K. When it reacts with H2O, it gives KOH, potassium hydroxide plus hydrogen gas. So this is also a base, this is also a base. So when high reactive metals reacts with the water, it gives hydroxide, low reactive metals gives oxides. Next is which gas is produced when dilute hydrochloric acid is added to the reactive metal. Dilute, so reactive metal, like any type of reactive metal, like magnesium, when it reacts with the HCl, dilute HCl, it gives MgCl2 salt plus hydrogen gas. Write the chemical reaction when iron reacts with the dilute H2SO4. So iron reacting with H2SO4 gives FeSO4, iron sulfate plus hydrogen gas. So this is what happens when iron reacts with the H2SO4, gives iron sulfate plus H2. Okay. Next, what would you observe when zinc is added to the solution of iron sulfate? Zinc on reacting with iron sulfate, FeSO4. Write the balanced chemical reaction. So if you see the reactivity series, so zinc is more reactive than the iron. Zinc is more reactive than the iron. So zinc when it dipped in the iron sulfate, it displaces the iron, gives ZnSO4 plus Fe. Single displacement reaction, metal reaction with the metal salt. So this is high reactive, low reactive metal can be displaced with the high reactive. Next, chemical properties of metals versus, so this is something mistake, okay. So here till now we discussed the metal and metal salt reaction. So next, after 5 minutes breaks, we will continue with the remaining topics. So utilize this 5 minutes break for the sake of water, drinking water, and have some snacks. Okay. Thank you so much for your attention. We will meet after 5 minutes. Okay. Thank you very much. Hello dear students, hope you all utilize this 5 minutes break for the drinking water, snacks and everything. So what we have discussed before this 5 minutes is the properties of ionic compounds. Sorry, here actually yes, before this is the chemical properties of metals and non-metals is, when the metals reacts with the non-metals. So we have discussed these questions already. So now metal versus non-metals. Metal versus non-metal was not discussed before the previous before the 5 minutes break. So metal versus non-metal reactions. So what happens when the metal reacts with the non-metals? So hope everybody joined the session. Yes, hello sir, hello. Yes, yes, yes. So metal versus non-metal reactions. Let me take one example. Sodium. Sorry, we will use white, which is the significance of peace. Yes. So sodium atomic number 11 and electronic configuration 2 comma 8 comma 1, and chlorine is a non-metal. How it is considered as non-metal? In previous slides only, in the first slide we discussed metals are the electron donating species, non-metals are electron accepting species. So chlorine atomic number 17, electronic configuration 2 comma 8 comma 7. So 7 means more than 7, more than 4, the atom will tries to gain electrons. So here it is 7. So it means the atom will tries to take electrons, whereas sodium will give the electrons. So after giving the electrons, sodium will be Na plus, and chlorine, after taking one electron, it becomes Cl minus. Cl minus. This plus and minus charges. Plus and minus charges are held together with some electrostatic attraction. That is nothing but the ionic bond. Electrostatic attraction. Electrostatic attraction. So what is electrostatic attraction? The attraction between the two oppositely species, ionic species, are nothing but the electrostatic attraction. That because of that electrostatic attraction, both metal and non-metal are held together with some bond. That bond is nothing but the ionic bond. Okay, remember, metal which donates the electron is called cation, non-metal which accepts the electron is called anion. Both metal ion, metal cation, non-metal anion are held together with some attraction. That attraction is nothing but the electrostatic attraction. That attraction is also termed as ionic bond, which is very strongest bond. Okay, so when metal reacts with the non-metal, gives a ionic compound which is very stable in nature. So here in the ionic bond, remember, in the ionic bond, the electron is donated from the metal to the non-metal. The metal is completely donating electron to the non-metal. Okay, there is another type of bond which is covalent bond. In that, the electrons are shared mutually. Metal or non-metal, which in that the metal or non-metal or metal or non-metal can make the bond by mutually sharing of electron. But here in the case of ionic bond, the electrons are donated completely from the metal to the non-metal. So ionic bond means metal can donate the electron to the non-metal, which is nothing but the ionic bond, which is metal and non-metal are held together. Metal or non-metal are held together. Sorry, there is a little disturbance. Hope you understand. So here metals or non-metals are held together. Metals or non-metals are held together with some attraction. That attraction is nothing but the electrostatic attraction, which is termed as the ionic bond. So next is the ionic bond properties. Ionic compound properties can be understood with the help of the activity 3.13. So what is that activity? So activity 3.13 suggests you the ignition test, solubility and the electric conductivity. So here, when salts are ignited, salts contains different types of metals. Metals, when they ignite with the help of heat, they will show the different colors. So this can be understood when you are going to the 11th grade. In the 11th grade, you have the metal properties. In that, you will do the ignition test for the different metals. Okay, metals, when they undergo ignition test, they will show the different flames, and that is nothing but the salt having high melting and boiling point, because salt contains a bond, any type of salt, not only NaCl, it contains a bond. That bond is called ionic bond, which is very strong, which is difficult to break. So melting point and boiling point of salts will be high. And electrical conductivity, when salts are dissolved in water, they will undergo decomposition like Na plus and Cl minus. Cl minus, not only Na plus and Cl minus, let us assume KCl. KCl will give K plus and Cl minus. Or salt, another example, ZnSO4 gives zinc plus 2 plus SO4 minus 2. Okay, these are the salts, when they dissolve in the water, they give plus and minus charges, which are responsible for the electrical conductivity. So these are the properties of the salts: physical state, melting point and boiling point, hardness, electrical conductivity, solubility and density and volatility. Okay, so physical state, they are crystalline in nature, ionic, arranged in the 3D lattice. 3D lattice means the structure of the ionic bond will be lattice structure, that is 3D structure. Okay, and melting point and boiling point. So the melting point of and boiling point of the salts will be very high, because they contain the strong ionic bonds, require much energy to break. Okay, next, hardness. Okay, so salts contains the metal and non-metal. They are held together with the ionic bond, which is strong. That is why salts are hard, brittle, shatter under pressure. Shatter under pressure. Lattice disrupts when like charges align. When the charges align, like charges align, the lattice will be broken. If the lattice is broken, then the hardness of metals will be decreased. So brittle, hard but brittle. So some salts are hard, some are brittle. Okay, electrical conductivity. So poor in solid. In solid state, they won't conduct the electricity, because in solid state we cannot found the ions, plus ions and minus ions. When they are dissolved in the water, remember, water is called polar solvent. So when you dissolve the salts in the water, they will give you Na. For example, if NaCl is dissolved in the water, NaCl is dissolved in the water, it gives Na plus and Cl minus. Okay, if zinc sulfate is dissolved in the water, it gives zinc plus sulfate. So these ions are decomposed because of H2O water. H2O water is called polar solvent. Remember, polar solvent, it can dissolve only salt. Okay, polar solvent. So here, electrical conductivity is poor in solid state, whereas good in the molten state or melted in the water. So ions mobile only when free to move. So salts, when they are dissolved in the water, it forms ions, they can move freely in the water. Okay, next, solubility. Soluble in water like polar solvents. Remember, water is called polar solvent. Salts can be dissolved in the water, which is called polar solvent. Insoluble in the non-polar solvent. What are non-polar solvent other than water? So example, ether, benzene, like organic compounds, they are called as non-polar solvent. Hydration of ions by water molecules. So water molecules makes the salts hydrated, that is why salts dissolves in the water. Density and volatility. What is volatility? Density means thickness. Volatility means converting the salts into gaseous states. So volatility, low volatility. Salts cannot easily react with the air. They won't directly convert into gaseous in the atmospheric air. Okay. So when they are exposed to the air, so they cannot easily get volatile. So tight packing in the lattice. Lattice is the structure of salt, which is very tightly packing of salt. That is why they won't get volatile. Okay. So these are the properties of the salts. So before the break, we didn't discuss these two slides. Hope you understand. So next, after the 5 minutes breaks, what are the topics we are going to study? So the questions are, write the electron dot structure of sodium, oxygen and magnesium. What is electron dot structure? Remember, electron dot structure means the outermost electrons of an atom can be kept as a dots around the atom. For example, sodium with atomic number 11, 2, 8, 1 electronic configuration. The outermost shell electrons are 1. So around sodium there will be 1 dot. And likewise, oxygen will be atomic number 6, oxygen atomic number 8, 2, 6, last electrons are 6. So around oxygen there will be 6 dots. And magnesium, Mg with 12 atomic number, 12 atomic number, 2, 8, 2, outermost shell electrons are 2. That is why around the magnesium there will be 2 electrons. Around the magnesium there will be 2 electrons, 2 dots. Okay, this is what the electron dot structure of sodium, oxygen and magnesium. Next is, show the formation of sodium oxide Na2O, magnesium oxide by the transfer of electrons. What are the ions present in the compounds? So here sodium oxide contains 2 Na atoms and 1 oxygen atoms. So sodium electron dot structure is Na plus, Na 1 dot, whereas oxygen with electron dot structure 6 electrons. So here, so this oxygen should make 2 bonds with the sodium. So oxygen should be kept dots around the oxygen. We should keep the dots in such a way that it should make 2 bonds with the sodium, 2 sodiums. So here, so this is how you can represent the bond between 2 sodium and 1 oxygen molecule. Next, magnesium oxide, MgO, magnesium with 2 dots and oxygen with 6 dots. So how can the bond formation between the magnesium and oxygen? Oxygen need 2 bonds, oxygen need 2 more electrons, so it can make 2 bonds with the magnesium. By placing its electrons, 2 electrons are paid electrons, remaining 2 electrons will be free electrons. Magnesium with 2 electrons, 1 bond here, 1 bond here, magnesium oxide, MgO. Okay, this is what the sodium oxide and magnesium oxide bond formation and electron transfer will be. Here the 2 electrons are transferred to Na, 2 Na will give 2 Na plus 2 electrons. Oxygen with 2 electrons will take 2 electrons, it becomes 2 minus. So 2 Na plus and O minus 2 will make bond in this manner. Okay, next. Why do ionic compounds have high melting point? So in previous slide we discussed that in the table the high melting point and the boiling point just because of the, let me know in the comment section, just because of the structure. What is the structure? The structure is named as lattice. So lattice structure is very strong, and also the bond between the metal and non-metal in the ionic compounds are very strong. That bond is nothing but the ionic bond. So the ionic compounds are very strong in nature. So that is why the melting point and boiling point is high. What are the examples for the ionic compounds? Are salts. Okay, the salts are the examples for the ionic compounds. Okay, that is why the melting point and the boiling point will be more. Okay, till now we completed the chemical reactions of the metals and non-metals. So metals in nature found as minerals, okay, ores, they are called as ores. So how can we extract the metals from the ores? So there are a lot of methods to extract the metals. So some of the methods we are going to discuss now in this session. Okay, so how metals exist in the nature? So metals exist in the nature as in the form of minerals that can be found in the earth crust. They are named as ores. Ores contain metal with non-metals, any non-metals with some impurities. So these are called as ores. Okay, the name of the ores, such metals like aluminum ore is bauxite with oxide, iron hematite or magnetite. Calcium can be found in limestone as carbonate. Sodium can be found in salt deposits, and potassium also silicates or salt deposits. Magnesium can be found in sea water or dolomite. So these are the ores which contains the metals that we want for the daily life activities. Okay, so here we want to extract these metals from the ores. How can we extract them? So what is the procedure involved in this method? So here the step by step extraction of metal will be, first we need to uh, I mean take the ore from the ground earth crust. That ore should be purified. How can we purify the ore? How can we extract the metal from that? So extraction of metal from the ore is called metallurgy. Remember, metallurgy means extraction of ore from the metal. Ore is extraction of metal from the ore is called metallurgy. So the procedure, the step by step procedure will be, first is ore crushed or grinded so that it should be converted into powder form. Why we need to convert into powder form? Because we should remove the dust from the ore. So with the help of dressing means washing, that is nothing but washing. So if there is a, like in ore, if there is a 50% of dust, we can make it powder, and when we wash it, the 50% can be eliminated as a impurities like gag. It is called as gag. Next, ore is getting concentrated. That concentrated ore is undergoing some reaction. That reaction is nothing but calcination and roasting. Calcination and roasting we will discuss in a detail in next slide. Okay, so calcination or roasting of ore converts the ore into metal oxides. That metal oxide on reduction gives metal. Crude metal on refining gives the pure metal. So step by step we will discuss every step of the extraction of metal. So first is crushing and making into powder form of ore, and dressing we don't discuss because dressing contains, washing, magnetic separation, there are some methods. Okay, so in our syllabus it is not included. So we directly start with the concentrated ore to convert into oxide. So first is extraction of metals. Under the extraction of metals there are two methods. They are new in the textbook: calcination and roasting. What are this calcination and roasting? So when ore is heated in the absence of air, in the limited amount of air, is called calcination, and when ore is heated in the excess of air, is called roasting. So in the reaction when we are extracting the metal, how this calcination and ore roasting are involved. Okay, so here first is extraction of metals low in the activity series. So what is the activity series? Potassium, sodium, this is high reactive. After the potassium, sodium and calcium, magnesium, aluminum, zinc, iron, there are many metals. Okay, so these metals, this is called the activity series. So based on the activity series, first we will take the low activity series metals. Okay, and under that we have an ore called cinnabar. Cinnabar is the ore of mercury. So mercury can be extracted from the cinnabar. So cinnabar, first mercurous sulfide are undergoing roasting. So why there is a need of roasting? Why we are making the mercurous sulfide to undergo oxidation reaction? Roasting also called as oxidation. Okay, remember in previous slide, calcination is also called as reduction. Oxidation is roasting is also called as oxidation. Roasting means heating of ore in the presence of air by air, that means oxygen is added. So heating of ore in the absence of air, that means oxygen is not added, oxygen should be removed. So that means reduction. Calcination is also called as reduction. Roasting is also called as oxidation. So here mercurous sulfide, when it undergoes reaction with oxygen, oxygen replaces sulfur, it gives mercurous oxide. So why we are replacing the sulfur with the oxygen? Because it is easy to separate the oxygen from the mercury. That is why we can replace the sulfur with oxygen. It gives mercurous oxide. Mercurous oxide on thermal decomposition. On thermal decomposition means when it is heated in the absence of air. When it is heated in the presence of absence of air, it releases its oxygen and this is the crude metal. Again it undergoes refining, electrolytic refining or any type of refining. It gives a pure metal. Okay, it gives a pure metal. There is another reaction, that is copper from the copper glands. Copper glands is CuS, copper sulfide. Copper sulfide, when it reacts with the oxygen, it gives copper oxide. This copper oxide, when it again reacts with the same copper oxide, or it goes self reduction. This is called self reduction. Self reduction means from this sulfur is removes the oxygen. This method is called self reduction. So it gives copper plus sulfur dioxide. So most of the times this question was asked in the exam. That means copper extraction, and in the copper extraction we can extract the copper with the help of self reduction method. This is called self reduction method. So copper sulfide reacting with the copper oxide, removing the sulfur dioxide gives copper. Okay, this is the extraction of metals of low reactivity. Low reactivity is this. Okay, next is another middle activity series. Middle activity series means in the activity series there are top, low reactive and middle reactive. Okay, there are unreactive metals also. So unreactive metals can be easily separated with the heating only, but the low reactive and middle reactive metals can be extracted with some methods. We have just now discussed the low reactive metals. Now it is middle reactive. Middle reactive metals like zinc sulfide, zinc with the sulfide, zinc with the carbonate can be extracted with the help of roasting and calcination. First, zinc sulfide. From the zinc sulfide, we want to remove sulfur. So when you add the oxygen, heating in the presence of oxygen, oxygen replaces sulfur. It gives zinc oxide plus sulfur dioxide. This zinc oxide, again it can undergo this reduction of zinc oxide. It gives reduction of zinc oxide in the presence of carbon. Carbon means coal. So zinc oxide in the presence of carbon, it takes away the oxygen, it gives zinc. Or else zinc carbonate, when it undergoes calcination, calcination means heating in the absence of oxygen. So CO2 is released out. So this zinc oxide again undergoes reduction of zinc oxide, same calcination. Calcination, this in the presence of carbon which is also called as reducing agent. This removes the oxygen, it gives zinc. Okay, this is one of the example of middle activity series extraction. So next is metals towards the top reactivity, and we have to discuss one more thing, that is in this case middle activity series there is exceptional case for the iron. So iron exists in the form of Fe2O3, which is called as hematite. So when we want to extract the iron, there is an exceptional case for the iron. We can remove this iron with the blast furnace. What is blast furnace? The heat, the temperature of the furnace will be around more than 1000 degrees centigrade. So we can extract the iron from that method, or else there is another method called iron oxide, Fe2O3, when it reacts with aluminum. It gives Al2O3 aluminum oxide plus iron. Okay, remember this method is called 3 oxygen. Now it is balanced, I think 2 higher 2 2. Now it is balanced. So this method is called as thermite reaction. So what is this thermite reaction? So thermite reaction is the reaction by which we can produce the molten iron. So how can we produce this molten iron? When iron oxide reacts with the aluminum, it gives aluminum oxide plus iron. This iron will be in the molten form. This molten iron is used to join the railway tracks. So this method is called as thermite reaction. Thermite process or thermite reaction. Remember this is very, very important. Iron can be extracted with the molten iron can be extracted with the help of aluminum. When iron oxide heated in the presence of aluminum, it gives aluminum oxide plus iron. This will be in the molten form. This molten form of iron is used to join the railway tracks. Okay. So hope you understand the middle activity series extraction. Next will be the extraction of metals which belongs to the top activity series. Okay, high reactive metals like potassium, sodium, calcium, magnesium, aluminum, they are high reactive, and if see, because of the high reactivity, it is difficult to extract the metals with the simple heating like oxidation or reduction. So they can be extracted with the help of electrolytic refining. So what is this electrolytic refining? So here, take two rods which is connected to the battery. This is called positive connected thing is called anode, and the negative is cathode. Okay, so here take the ore, like example, not only KCl or NaCl. Let me take example of NaCl, powdered form of NaCl. From this we want to extract the sodium. So powdered form of the NaCl is dissolved in the water. When it dissolved in the water, it gives when it is dissolved, when I already told you that when salt is dissolved in the water, it gives two ions, plus ions and minus ion, Na plus and Cl minus. This Na plus charges will move towards the negative charge. So here you can found, so here in the near the cathode we can found sodium, whereas near cathode we can found chlorine. And this method is called as electrolytic reduction. Why it is called as reduction? So here sodium Na plus will be Na plus, okay, chlorine will be Cl minus. So from chlorine the electron is removed, it gives one chlorine plus one electron. This electron is given to the sodium so that it can convert into, taking one electron, it becomes Na. So we want only Na, not Na plus. Okay, so here from the chlorine the electron is removed. Electron is added to the sodium. Addition of electrons is also called as reduction. Addition of hydrogen, removal of oxygen, or addition of electrons is also called as reduction. So from the chlorine the electron is being added to the sodium, it becomes Na. So we want Na, not Na plus. So that is why it is called as electrolytic reduction, electrolysis. So when salt is crushed and dissolved in the water, the opposite charges move towards the opposite poles. Na can be collected, sodium can be collected in the cathode. Cathode is a negative terminal. At negative terminal the positive charges will accumulate. Positive charges are nothing but the metals. Metal can be obtained at the cathode. So here from the chlorine non-metal the electron is removed and it is added to the metal, which gives a pure form of the metal. So this is nothing but the electrolytic reduction of the top activity series metal. Okay, electrolytic refining. So till now we completed with the extraction of metals with the help of calcination, roasting, and calcination and roasting are involved in the extraction of low reactive or middle reactivity metals. The top reactive metals can be extracted with the help of this method is called electrolytic reduction method. So till now we completed with the extraction of metals. Next, electrolytic refining. What is this electrolytic refining? So electrolytic refining which gives the pure metal from the crude metal. So crude metal can be converted into pure metal with this method. So one of the example is copper extraction. So how can we extract this copper? So let us assume this anode is a copper impure rod. It is a crude copper. Crude copper means impure copper. It is a impure copper. Whereas this cathode is a pure copper. It's a pure copper. And it is also here, it is dissolved. The electrolyte is CuSO4 copper sulfate. So in this method we should use everything same metal. So copper, impure copper, from this we need to extract the copper. This is called pure copper, which is at cathode. Cathode is pure copper, anode crude copper. So always remember, at anode you can place the impure one, at cathode you can place the pure one. So what happens when you connect it with the battery? So here from the copper here from the copper. So here anode contains the copper ions. Cu will be, so Cu will be +2, copper will be +2, which is called as cation, which move towards the cation will move towards the cathode. Cations will move towards the cathode and it will accumulate at the bottom of the beaker, that is bottom of the beaker. Here is the copper mud. So you can extract the copper from this method, which is called as electrolytic refining. See, after extracting the crude metal means from the ore the metal is extracted, that metal is considered as crude metal. So from the crude metal you can extract the metal with the electrolytic refining. In the electrolytic refining, all should be same metal. At cathode it should be pure, at anode it should be impure. You can take the metal salt in the electrolyte as the electrolyte. Okay, so hope you have understand till now. Till now we have discussed the electrolytic refining. So next is corrosion. So there is an activity for corrosion. Take 3 test tubes A, B, C. A contains the metals with the water and air. B contains metal nails, which is a iron nails with the water, and top of the water layer we have added the paraffin, which does not allow the air. So water is present but oxygen is not present. So here anhydrous calcium chloride. Anhydrous calcium chloride means calcium chloride will absorb the moisture and the atmospheric air. So calcium chloride here makes the air dry. Okay, so there are different types. So what are the observation you can find in the tube A, air and water. So both oxygen from air and moisture present, so rusting occurs rapidly. So in test tube A, rusting occurs rapidly, whereas in test tube B, test tube B, boiled water, it is boiled water, not cool water, boiled water. Air removed by the boiling and sealed with the oil. So lack of oxygen, lack of dissolved oxygen prevents the rusting. So here in the test tube B, you cannot find the rusting. So whereas in the test tube C, dry air, calcium carbonate absorbs moisture, leaving the only dry air. So no rusting takes place. So in the test tube B and in the test tube C, you cannot find the rusting just because the absence of oxygen. So finally that we can conclude that the rusting stops when the either oxygen or water is absent. So water and oxygen is responsible for the rusting. So confirming both are essential factors. So for the rusting we need oxygen and water. Without the oxygen and water the rusting cannot occur. So to prevent from the corrosion, we need to make a metal in a such a way that it should not react with the water, it should not react with the oxygen. So what are the preventive measures? So preventive measures of corrosion will be first barrier coating. Barrier coating means, so there should be a barrier between the metal and the atmosphere. So we can paint the surface of the metal, that is greasing the metal or painting or applying the oils, so that it prevent from the atmospheric air. Or galvanization. Galvanization is the method by which the metal can be coated with a metal which is zinc on the surface. So coating of zinc on the metal surface is called galvanization. Next is called cathode protection. What is cathode protection? This is also called as like plating of electroplating. It is called as electroplating. Attaching a more reactive metal or using an external current makes the iron a cathode. That means electroplating. It is also called as electroplating. And last, this is not included in your syllabus. Don't take it. Okay, this is not included in your syllabus. Barrier coating and galvanization. Last is alloying. So alloying, what is alloying? So alloying is the procedure by which the two or more metals are mixed together so that it should not react with the atmospheric gases, which makes the metal prevent from the corrosion. So here using the corrosion resistant alloys like stainless steels or reduces the susceptibility. That means metals, when they are mixed with the less reactive metals, that makes the metal prevent from the corrosion. So what are these alloys? What is the composition of alloys? So alloys prevent corrosion by mixing the metals with other elements to create more resistive materials, then form protective oxide layer or reduce the reactivity. So here metals are mixed with the other metals, it makes the metals less reactive, so it can be prevented by the corrosion. So what are these alloys? So what is the composition? So first alloy is brass, which contains copper 65 to 80%, zinc 20 to 35%. So mixture of copper and zinc. It is used in the musical instruments and decorative items, coins. Bronze contains copper and tin. Steel contains iron, carbon and some other metals like chromium and nickel. Stainless steel contains iron, chromium, nickel, carbon and small amount of something. Okay, so here there is a metal with the non-metal is called stainless steel. Stainless steel or steel, it contains the carbon which is a non-metal, so it is used in the alloy formation. So remember, they will ask you which type of alloy contains a non-metal as a composition. So this stainless steel or steel. Duralumin. Duralumin is a alloy which is used in the kitchen like aircraft or vehicles. So it contains aluminum, copper, magnesium and manganese. Okay. So last is nichrome. So nichrome is a alloy, it contains nickel, chromium 15 to 20% and nickel. So it is used in the toasters, electrical appliances as heating elements. So this is about the alloys. So this was the last topic of your unit 3, metals and non-metals. So hope you understand everything from this unit 3. If you have any doubts or queries, you can ask in the comment section. No sir, thank you so much. Thank you. Yes. Can we discuss the in-text question? Yes. Next slides, they are going to be same. Okay. Next slides are NCERT in-text questions. So first, which of the following pairs will give displacement reaction? So first is NaCl plus copper metal, NaCl plus copper. So copper is less reactive, which cannot displace the sodium from the sodium chloride. It is not possible. Magnesium chloride with the aluminum, MgCl2 plus aluminum. Aluminum is less reactive than the magnesium. It cannot also displace the chlorine from the magnesium from the magnesium chloride. Fe, SO4, iron sulfate plus Ag, silver. Ag is less reactive than the iron. It cannot also displace the iron. Whereas AgNO3, silver nitrate, AgNO3 plus copper. Copper is high reactive than the silver. It can displace the Ag. It gives CuNO3, copper nitrate, CuNO3 taken twice, copper nitrate plus silver. Okay, this is the correct option. Next, which of the following methods is suitable for the preventing an iron frying pan from rusting? Applying a grease? Yes. Applying also grease. Applying paint? Yes, we can use applying paint also. Coating with the zinc, galvanization? Yes. So all of the above. So these all are correct. So this will be the answer. D. Option D will be the answer. All of the above. But applying grease is not good because frying pan we use it for the cooking. So applying grease is not taken into consider. But prevention of metals can be considered as applying grease. But here frying pans, applying grease is not applicable, but we can consider all of the above here. Okay. Next, an element reacts with the oxygen to give a compound with the high melting point. The compound is also soluble in water. The element is likely to be. So the element reacts with the oxygen. So carbon, silicon, oxygen. First, let me tell you, iron when it reacts with the oxygen, it gives Fe2O3. Fe2O3 does not react with the water. he said high melting point, this compound is soluble in water. This compound does not soluble in water. Whereas calcium, Ca, when it reacts with the oxygen, it gives calcium oxide. In the presence of water, it gives calcium hydroxide. So it completely dissolves in water, which is nothing but calcium oxide. So calcium will be the metal. Okay, next. Food cans are coated with the tin and not with the zinc because food zinc is costlier than the tin. Zinc has high melting point than the tin. Zinc is more reactive than the tin. Zinc is less reactive than cell. Yes, zinc is more reactive than the tin. So that is why we should not use the zinc for the cans, food cans. We can use tin. Okay, tin. And also zinc is toxic in nature. It is not edible. Okay. So we can, zinc is more reactive than the tin. That is why we should use tin in the place of zinc for the coating food cans. Next, you are given a hammer, a battery, bulb, wire and switch. So how could you use that to distinguish the between the samples of the metals and non-metals? So with the help of hammer, we can use the hammer to check the property of malleability. So when you hammer the metal, so it makes a fine sheet, that is the property of malleability. Only it can be possible with the metals, whereas non-metals does not. And battery, bulb, wires. So with the help of electrical conductivity, we can differentiate the metal and non-metal. So here, metal and non-metal can be differentiated with the help of malleable and electrical conductivity. Access the usefulness of this test in the distinguishing between the metals and metals. Sorry. So metals and non-metals can be distinguished with the help of the properties, malleability here and the electrical conductivity. Okay. So next, what are amphoteric oxide? Amphoteric oxide, one of the examples is Al2O3. Amphoteric oxide. So Al2O3 will be the amphoteric oxide which reacts with the, mostly it reacts with acids and bases. Mostly it reacts with acids and bases. They can exist like they won't react with the water mostly. So amphoteric oxides, and give two examples for the amphoteric oxide. So you can take aluminum oxide or iron oxide, Fe2O3. This can be aluminum oxide or iron oxide. Next, state two ways to prevent the iron rusting. So two ways: coating with the metal, but that is nothing but the galvanization, and also we can mix it with the other metals by making the alloy. But iron should be same physical form, so we can paint it with the any other paints. So benzyl chemical, benzene based paints. So paint it with the paint, or else we can coat with the zinc. That is nothing but the galvanization. So one preventive method is galvanization, other will be painting or coating. Okay. So hope you have understand completely about the unit 3.